All right, so polar coordinates. I'm going to teach you how to graph. Shh. So we've done, obviously, your regular rectangular points on a graph. Okay, we've talked about parametric equations on a graph. This is another type of graph, which is called polar coordinates. So 9.5 is polar coordinates, learning how to plot literally a point in polar. And then 9.6 is polar equations, where I'm going to teach you how to graph shapes on a polar coordinate grid. Okay, so a polar coordinate system is formed around a fixed point, which is labeled O, called the pole. It's the same as the origin. So if I had an x-axis and a y-axis and they cross at the origin, now we have what's called the polar axis and the y-axis that crosses at what we call the pole. And then you construct from O, so from that point, an initial ray called the polar axis. So what's going to happen is our x-axis is now labeled the polar axis. This is now labeled the pole. And then we find a coordinate based on an angle and a length. So the r is the directed distance, which technically is kind of just like the radius if you had drawn a circle. This time the radius is not always 1. So up to this point when we talked about unit circle, our radius was always 1. Now we're extending that. We're still using theta as in radians around our circle. You can also see polar in degrees, but we'll focus mostly on radians. So each point in the plane can be assigned polar coordinates. They are in parentheses just like your x and y coordinates, but the first number represents the directed distance, or that radius. And the second number represents the angle that would be drawn from your polar axis up to that ray. So they will look similar to your rectangular coordinates in that there are parentheses with two numbers separated by a comma. Most of them will be in radians, so you'll see things like pi or pi over 6 or 11 pi over 4, something like that. You could see degrees in there. You also might just see 0, and then you wouldn't know the difference because there's no difference between 0 as in a rectangular grid and 0 as in a radian. But that in those cases, it'll be labeled as polar coordinate. Anthony?
You go back to it.
Mm-hmm. All right, so to plot the point, I'm actually going to pull in a polar axis. So if you went to Safari and you search for polar grid, there's lots of them because they can be different number of rings. But an example of what one would look like would be this. So this would be a polar grid. It's like a circle. It's almost like a bullseye on top of a rectangular coordinate grid. So if you look closer at this, you can see that it has these rings. So this would be 1, that's your radius of 1. Here's 2, that's a circle with a radius of 2. 3 would be 3 units out. 4 would be 4 units out, and it can keep going. So a lot of them have 10 rings or 5 rings, however many rings. It doesn't matter as long as you use the distance you need to use. And then notice that this starts at 0. This doesn't have all of your special angles. It goes 0, pi over 4, pi over 2, 3 pi over 4, pi, 5 pi over 4, 3 pi over 2, 7 pi over 4. In between there would be pi over 6. This would be pi over 3. These are 1 less than the denominator, if you remember. 2 pi over 3, 5 pi over 6. This is 1 more than your denominator, 7 pi over 6. 4 pi over 3. And then this one was 5, 7, 11, or 1 less than double. 5 pi over 3, 7 pi over 4, and 11 pi over 6. So by next test time, which is a week from Wednesday, you want to make sure you have that whole unit circle.
That's a lot of information.
I told you it wasn't going to go away. For Wednesdays, you just need that first quadrant, but obviously you need the first quadrant, you need the points, you need the tangents, all that stuff.
Wait, for this one? Yeah.
For this Wednesday, in order to do the rotation of the conics, you need to know that first quadrant. Right?
Only the first quadrant?
Only the first quadrant, yeah.
Right, so 5 over 6, 5 over 4, 5 over 2, 5 over 2.
Correct.
That's it, it's all good.
For the rotation of conics, yep.
You know the sign
You need to know the sine, the cosine, because that goes into your x and y. And you need to know the tangent, because that gets you theta.
Or is it even the coordinate?
And tangent. Yep.
Wait, so we need the tangent, we can't just use the cosine and sine?
Sure, it just takes you longer.
Okay.
Yeah. All about management of time, right?
So I have to take this test. Yeah, right? We're not gonna miss this. Or are we gonna be done?
No, no one's going to, no, only AP. Wait. Oh, now we got to figure out how to graph these. So the second part of my parentheses is the angle in which I'm going to go along its ray. So if I go pi over 3, then I'm going up to pi over 3, and I want to go along this ray that's here. The first number is how far out I go, how many rings out I go, okay? So if it was a 1, I'd go out to the first ring. If it's a 2 like it is, I'm going out to the second ring, and I plot a point, and that is the rectangular, that's the polar coordinate.
Wait. First you draw the...
First you don't even have to draw it. You just have to know where to go to. You have to know to go to pi over 3, right, which we know is there. So I could erase all that extra stuff off because that's not really technically part of my answer, right? My only answer
Then you go
is that point.
Then you go 2 like lines above it, like...
Right, because it was 2. Yep.
So that's it?
That's it.
This isn't bad. So technically you're starting with, oh, 1, 2, and then...
The middle circle is 1.
It says it. Look at there's a little 1 on that middle circle.
Oh, I see.
Because your graph could look, I just went to Safari and grabbed the first polar grid one that I could find. Yeah. So, but the line is not part of it, just the dot. We're plotting a coordinate, okay? So it's just the dot.
The next one's negative.
All right, so next one's negative pi over 6. Where does that happen? Underneath the first pi over 6, below the x-axis, right? So it's going to be along this line here, at that 11 pi over 6 line. And it's 3 this time. So along that line, I'm counting out 1, 2, 3, and plotting a point. And that's that one.
And that's the answer.
Yep, super easy, just plotting a point so far.
So
So far. It's example 1. It doesn't usually stay at that level. It doesn't get much harder, but it does get a little bit different. And tomorrow we're going to learn how to on Thursday, fill a graph with a bunch of these points because we're going to graph polar equations, okay? All right. So A, go ahead and you do. See if you can do it on your own. All right, so 11 pi over 6, we would know that would be around here at 11 pi over 6. And it's 3 out, so I'm going, let's say this is 1 ring, 2 rings. This would be the third ring. That would be your point, okay? Everybody's okay on that, right? Yeah, okay. Yeah, I just got one that had less rings, but it's still, just be prepared to do it. Even if I just gave you a blank circle, could you be able to draw it? That's all you need to do. Test-wise, I'll give you one so they're not all different, but just get used to seeing them because that one could be different. Yep.
I have a question how this one is a 3 and 11 pi over 6, and the other one, for the other problem, B was 3 and negative pi over 6, and it was the same point.
Yep.
So it would be...
Those are coterminal angles, right?
Okay.
So every time around that circle would give you the exact same result, which actually leads into what we're going to do next. So B says negative 3. This is where it's different. So the 11 pi over 6 would be the same angle, except that the radius is now negative. So when I go to find a negative radius or negative polar distance, then instead of going in the direction of the angle I want to go, I would draw a ray in the opposite direction and then move that way. So if 11 pi over 6 was here, then I'd be going in the opposite direction here, and I'd be going out 1, 2, 3 spaces, and that's where the negative 3 would go. So it moves away from the angle that you'd be trying to get to. Does that make sense? Negative goes opposite direction.
So you're still doing the 3 rings?
Still 3 rings. Yep, it's just in the opposite direction. All right, so in finding additional points, which kind of leads to what you just asked about, the point r theta can be represented as r theta plus 2n pi, which means if I went to pi over 3 and plotted a point along that angle, I can also add 2 pi to that and end up in the same spot. Or I could subtract 2 pi from that and add up in the same spot. I could add 4 pi. I could add 6 pi. I could keep going by multiples of 2 and still end up at the same point. And these are not angles, so you won't see, remember we used to draw, like if it was 6 pi, we used to draw the little arrow around and around and around to get to the terminal side. These have no bearing. You'll have no idea that they're different, okay, because there's no arrow or direction. If it's r theta, it also could happen at adding and subtracting 1/2 the pi by changing the sign, or 1/2 the 2 pi, which is pi, by changing the sign on the radius. Okay, because think about if it's negative. So let's just say I went to pi over 4 and it was 2 pi over 4. So I plot my point, 2 pi over 4. So this first one is saying if I add 2 pi, so that I'd be at 9 pi over 4, I'd be back in that same spot. So 2, 9 pi over 4 would also give me the same rectangular coordinate, right? Mm-hmm. Same thing if I subtract 2 pi, so 2 and negative 7 pi over 4 would also be that same point on my circle. The other way to get those same points is by doing halfway around the circle. So if I made it out to pi plus pi over 4 or 5 pi over 4, but instead of moving in the positive direction, I move in the negative 2 direction, I also get the same point. So negative 2, 5 pi over 4 gives me that same point. Does that make sense? Mm-hmm. And any coterminal with that would do the same. So I could add 2 pi onto this, or I could subtract 2 pi from that, and I'd still end up at that same point. So you're going to see questions that say this. Plot the point, and then find 3 additionally polar representations of this point using negative pi over 2 is less than theta, which is less than 2 pi. So first start with your actual coordinate grid. So 3 pi over 4. Negative 3 pi over 4 is over here. Positive 3 means I move from the pole 1, 2, 3 rings out, and my point would be there. With me so far?
It would be negative 3 pi over 4 to negative 5 pi over 4. Negative 3 pi over 4 going to 4.
So now you want to find another representation. Oh, is it at 5 pi over 4? Yes.
Like it's right before.
Yes. Okay. So how else could I label this exact same point? What's the easiest thing to do?
Plus 2 pi. And
add 2 pi, subtract 2 pi. So if I took negative 3 pi over 4 and I added 2 pi, which would be 8 pi over 4, I end up with 5 pi over 4. Does that fall between negative pi over 2 and positive pi over 2? Yes. Yeah, so that's one way I could rewrite this. 3, 5 pi over 4.
Wait, why did you add 8 pi over 4?
Because I added 2 pi. I want coterminal, so I'm going all the way around the circle one more time back to that same spot.
And then negative 11 pi over 4.
So then try going subtraction. Negative 3 pi over 4 minus 2 pi, which would be 8 pi over 4. What's wrong with negative 11 pi over 4? It's too small, right? It moves behind negative 2 pi. So I can't use that one.
Okay.
Those would be 2 points. Yeah, it would be 2 points.
Mm-hmm. So how else could I get those same points? I could change it so that it's negative. So what angle would I be forming if I wanted to move away from that to get to the left side of, or this third quadrant? Where would be an opposite ray? Good. It's got to make a line with it, right? So opposite ray would be pi over 4, but this time I don't want it to be a positive 3. I want it to be what? Negative 3. And then it can be coterminal with that, right? So I could take pi over 4 and add 2 pi, or 8 pi over 4. But again, too big. So then try subtracting, and I get negative 7 pi over 4. Is that bigger than negative 2 pi? Yeah, so it works, right? So I would do negative 3 and negative 7 pi over 4. So those are the 3 ways that you can represent the same point within the range of negative 2 pi and positive 2 pi. Kayla.
So the reason you can't use 9 pi over 4 is because it's more than like what's shown in the 2 pi.
Exactly. Like this time it said make sure it's in between negative 2 pi and positive 2 pi. If it didn't say that, then you could give me more than one answer.
Okay.
You could keep going. Dominic.
And the reason why you were able to do -3 and -7 pi over 4 is because it's on the opposite side.
Right, I'd be
of the
using
original.
this ray, but moving away from it, which gives me that same point.
You're using that ray.
That's pi over 4, and that's -7 pi over 4.
Oh, okay.
Does that make sense?
The one you just highlighted.
The one I
is
highlighted would be pi over 4. Yep, sort of,
So
but
where
yeah.
do we start? We started at the one that's got the dot on it.
So first you graph the initial one, and then you want to find either coterminal to that point, right? So I added 2 pi, I subtracted 2 pi, but it had to fall within my -2 pi to positive 2 pi range.
So it's on the same line.
That would be the same point. Or use the negative radius and use the opposite ray angle. So if this is my original angle, then opposite ray would be this way, which is pi over 4, but negative radius. So you want to change the sign on the radius.
So why did you use -7?
Because we needed one more after that. So coterminal to that last one would be pi over 4 plus 2 pi, which is too big, or pi over 4 minus 2 pi, which is -7 pi over 4.
How'd you know to start to use pi over 4?
Because it's opposite. It's the opposite ray to 5 pi over 4.
And then you add 2 pi and subtract 2 pi. But
Yep.
what are you trying to find?
I'm trying to find, basically, including the one they gave me, 4 ways to say the same point. So if I had given you 4 questions and it was 3,
3 ways of
well, including the initial question, there's 4 total ways, right? These all, if I asked all of you to graph these, and the initial one, they're all the same exact point.
So you don't even need to.
How come you have a line going across?
Because I had to find the opposite ray to be able to change the sign on the radius. So making the radius negative means I have to find the angle in the opposite direction. So let's just say that my graph was originally in the 4th quadrant and it was positive 2, right? So let's say it was 2 and 11 pi over 6.
Then you'd have to go 5 pi over 6, -2.
Exactly. Does that make sense? I'd be going the opposite direction, making the opposite ray, which would be 5 pi over 6, but my r would now have to be negative. Does that make sense? Yeah?
Yeah.
Okay.
Renaming it for the same.
Yep. All right, coordinate conversion. So now we're going to figure out how to go from rectangular to polar or polar to rectangular. Rectangular is your typical x and y. If I told you to plot 1, 3, you'd go to the right 1, up 3, plot a point. That's rectangular. Okay? So we're trying to figure out the overlap between them. To establish the relationship between polar and rectangular coordinates, let the polar axis coincide with the positive x-axis and the pole with the origin. So as though you'd be overlapping the two together. Okay? We said the pole is just like the origin. We said the polar axis is just like your x-axis. Now we're going to literally overlap the two. Not physically, but you can kind of do it in your head. So because the xy lies on the circle of a radius r, it follows that r squared would equal x squared plus y squared. Moreover, for r being greater than 0, the definitions of the trigonometric functions imply that tangent of, this is SOHCAHTOA, tangent of theta would be y over x, cosine of theta would be x over r, sine of theta would be y over r. So those 3 boxes you don't need to memorize. However, those get you to what's on the bottom, and that's what you've got to know. So you can show the same relationships hold for r is greater than 0. That to get from polar to rectangular, so we're going something like 2 pi over 6 to a rectangular that I want an x and a y. The x is found by doing r, which is that first number, times the cosine of the angle, and the y is found by doing r, which is the radius, times the sine of that angle. So in order to get there, I would get 2 cosine pi over 6, and I would get 2 sine pi over 6. And this is why you have to know the x and y's around your unit circle, because then you'll plug those values in, simplify it, and get your answer, which would be in coordinate form, okay? So that's polar to rectangular, which we'll work out an example in a second. The opposite is rectangular to polar. So if I gave you something like 2, 3, you'd have to use that to get the angle first. So the tangent of theta is y over x, which is something we've known for a long time. And to get theta, we would do tangent -1 of y over x, or if it's on the unit circle, figure out what angle has that value of tangent, which you have to know for rotation of conics anyway, so it's good to review it. And then the second thing you have to do is find r, which is x squared plus y squared equals r squared.
That's just from rectangular to polar, so we find tangent and then we just put in an equation.
You're going to find tangent, and then you're going to find tangent -1. So you're going to find the angle that has that tangent.
Oh, wait, why do we need to find tangent -1?
Because you're actually looking for theta. Remember, these are going to be in radius, so it's going to be a number, and then it's going to be a theta.
I see.
So you're finding two things, radius and theta.
Okay.
Okay? And all of it relies upon the fact that you're making that initial triangle, right? Anywhere on your unit circle, you can flip this around in any direction. But this is going to be your x value. This is going to be your y value. This is your r value. The difference between this and unit circle is unit circle, the r was always 1. Now it's not. So you'll actually figure out what r is by doing the Pythagorean theorem. And then you'll figure out what the theta is by using the inverse of tangent. So it says, when showing the answer in rectangular form, you're going to write the answer as x, y equals number, comma, number. So if you're giving me the answer and you want to show me that this is a rectangular form, then your answer is going to look like that. X, y equals, and let's say it's 2, 3. That's how you'll know the difference between rectangular and polar. If you're showing the answer in polar form, then you'll write the answer as r theta equals 2 pi over 6. And that's how I'll know that that's supposed to be in polar form. Most of the angles are easy to decipher. I know if it's pi over 6, you're talking about an angle. But is there an angle that has 0? Yes, right? And how would I know the difference between that your intention for that to be polar or rectangular? Okay, you'll write it out like that. All right, convert the point 2 pi to rectangular coordinates. So just like with all the conics, I would say probably try to draw yourself a visual so you can get it in your head what this would look like, because it will help you make sure that your answer's right. So 2 theta means 2 pi means I'm going to the angle where pi is, which is where? On the left-hand side. And I'm going out 2 units. So the coordinate would be there. Could you already tell me the rectangular coordinates on that one? -2, 0, right? You didn't even need the formula for that. They're not all going to be like that, but that already you can tell. Because I'm moving left 2 and not up or down at all. So you go back to your typical x and y coordinates. Because I'm moving left. I'm x, y coordinates, not polar. Go back to before today. If I had plotted that point on an x, y coordinate grid, right? So this is rectangular. That's before today. Now polar is how we graphed it initially. Does that make sense? So you're overlapping the two. So then to actually get the equation, let's say it wasn't as obvious. X is r times the cosine of theta, and y is r times the sine of theta. So x equals 2 cosine of pi, and y equals 2 sine of pi. Now on your unit circle, not with radians, not with the radius, not with polar, but on your typical unit circle, if I was to go around this circle, what would be the point at pi?
Wait, 1?
-1, 0, right?
Mm-hmm.
So the cosine is what?
Cosine would be 2 multiplied by -1?
Yep.
Oh.
And you'd get -2, and the sine is 0, and you'd get 0. So that's your x, that's your y, and you'll write your answer as x, comma, y equals -2, 0.
What a pain.
Can I see the graph here?
The one at the top?
Yeah. The coordinates of pi is -1, 0.
On your unit circle. So this is based on your initial unit circle. Good.
You go to the line. Like if you're doing x equals 2 cosine pi, you find the line that your original equation is on, the point is on, and that's
No, I go to my unit circle. So 2 cosine theta, think about your unit circle, right? Your unit circle had 0, pi over 2, pi, 3 pi over 2, right? All the points, the 3 angles in between on each of these, because any of these are fair game. We just happen to use pi this time. So pi's over here, and on my unit circle in pi, which has a radius of 1, the coordinate is negative 1, 0. Oops. Which means this is my cosine, and this is my sine. So when we're plugging the values into the equation, we're using the unit circle.
Let's say the equation was like, it said 2 and then 3 pi over 4. You would go to the coordinate points of 3 pi over 4.
When you do x equals r times the cosine, yes, you're going to those. Yep, which is, B says root 3 and pi over 6, right? So I would say, first of all, I would approximate what it looks like so I have it kind of in my head. Root 3 is like a 1.5. Pi over 6 is here. So at least I know I'm in the first quadrant, which should kind of help make sense when I get my points at the end. But I don't need that. That just helps. So then x would equal the radius, which is root 3, times the cosine at pi over 6. And y equals root 3 times the sine of pi over 6. So again, if you use your unit circle, this sloppy one over here, my pi over 6, which is root 3 over 2 and 1/2, which you have to know for this week's test and next week's test. So root 3 would get multiplied by the cosine there, which is root 3 over 2. And I get root 3 times root 3, which is 3 over 2. And the root 3 would get multiplied by the sine of pi over 6, which is 1/2. Root 3 times 1/2, which is going to be root 3 over 2. So the answer to that would be x comma y equals 3 over 2 and root 3 over 2. And to approximate that, that'd be like 1.5, and then that's like 1.4 divided by 2, so it's like 0.7, which would put it pretty close to where we estimated it to begin with.
I'm a little lost.
Where'd I lose you?
The points, square root 3 and pi over 6 on the.
So you're good to here.
Yeah.
Okay, so then I have to go to my unit circle, which is really sloppy over here, but I'd go to my unit circle, and I'd find both the sine and the cosine at pi over 6. So the coordinate point at pi over 6 is root 3 over 2 and 1/2.
Okay.
The cosine is your x. The sine is your y.
All right.
And then you just plug it in and simplify. So I plugged in the cosine and the sine, and then I simplified by multiplying by the radius, which is root 3.
Oh, okay. All
Does that make sense?
Yeah.
Yeah, okay. Now we're going the reverse. So now this is in rectangular, and it says to convert to polar. So we said we had 2 pieces of information we needed to use for polar. One is that r squared equals a squared plus b squared, because we have to figure out what the radius is. And the other is that the tangent of theta equals y over x. So again, give yourself a little approximate. Convert to 2, so up or 2, up 2. There's my point. What angle you think it's going to be at if it's directly in between the x and the y?
45.
45 degrees or pi over 4. So let's see if we're right. So first thing I'm going to do is the radius, which would be r squared equals 2 squared plus 2 squared, 4 plus 4. R equals the square root of 8, or 2 root 2. And tangent of theta equals y over x, which is 2 over 2. Tangent of theta is 1, so we're looking for the inverse tangent. So what angle has a tangent of 1, which again you need to know for Wednesday, and that's pi over 4. So my answer is going to be r comma theta equals 2 root 2 comma pi over 4.
We're having a little bit of 9-5.
Are you with me up to here?
Mm-hmm.
So r squared equals what? Negative 1 squared plus 0 squared. 1 plus 0 is 1. Square root of 1 is 1. Remember, we always keep the radius positive. So that's technically plus or minus 1, but we always keep the radius in when we're solving it for 1 as positive. Then I get tangent of theta is 0 over 1. Tangent of theta is 0. And where on my unit circle is tangent 0?
0.
So it is 0 at 0, which would mean that this is 1, 0. What's wrong with what we graphed as our estimate and what we got?
One's negative, one's positive.
It should be a negative, right?
So it's pi over 2.
Nope.
Uh,
Why is it pi? So tangent is also 0 at pi, yes? Right? That's what we have to fall on our estimate to begin with, because technically there's two angles. There's 0 and there's pi, and you use your graph to tell you which one's the right one to pull. So this would be pi.
So 1 comma pi?
Yep.
Dang.
So for the test on Wednesday, like for our rotation of the conics, I said I'm going to keep it in the first quadrant. But by next week's test, your whole unit circle is fair game. Questions on any of those? Yep.
Because, like, if you, I don't know why you chose pi instead of 0.
So because when we graphed it, look at where that point is. That's at pi. More obvious than that is it's not at 0, right? So I knew something's wrong. There are 2 places on my unit circle in which tangent is going to be every value. There's 2 places where it's 1, positive 1. There's 2 places where it's negative 1. There's 2 places where it's root 3. There's 2 places where it's negative root 3. So you have to approximate where that graph is going to lie in order to figure out which of your 2 options is the right option.
So everything is 0.
Tangent? Yeah, if it was, what do you mean? It could be 0. If my radius was negative, it could have been. Yeah. Okay, the last part is the good news. This is the easy part. This is where your calculator does the work for your brain. You just have to know how to use your calculator.
Well, what if you did not bring it?
If you didn't bring your calculator, then you can practice this later.
Okay.
All right, so note 2 things about what it says there at the top, that your calculator must be in polar and radians. Remember last week when we looked at this and we put it into, or not last week, maybe the week before, we put it into parametric mode, that on that same line, there's also the option to put it in polar. So we want this in polar form. So I'm going to go down to where it was parametric. Make sure you click on polar and enter so it goes to polar. The other thing is all the theta that we have been doing are in radians. So you want to make sure that your graph is also, or your function is also set to radian instead of degree. With me so far? Okay, because otherwise everything else after that will be wrong. Okay, so this question says convert the point 2.5, 1.58 to rectangular coordinates. So I'm going from polar to rectangular, okay? Which falls in the little menu that says angle. So second apps is your angle menu. Remember this DMS, right? Our degree, minute, second notation. If you look at 5, 6, 7, and 8, those are what we're using. So 5 and 6 are R to P, which stands for, what do you think? Rectangular to polar. And it's R to PR and R to P theta, which means the first one's going to give you the radius. The second one's going to give you the angle, okay? And then underneath that is P to R and P to R, P to RX and P to RY. So that's polar to rectangular X coordinate and polar to rectangular Y coordinate. So here we're going from polar to rectangular, which means I'm going P to RX first. And I'm going to type in those coordinates. 2.5, comma, which is above the 7. 1.58. And I'm going to hit enter. And that is my X coordinate. Negative 0.02. So it'll tell you what to round to, but I think actually homework says 3 decimal places, so I'm going to go one more.
Negative points above 0.
You have to close the parentheses.
No, I don't think so.
I got negative 0.022.
Negative 0.023?
Negative 0.02. That's what.
No, you're missing a 0. You're in polar and you're in radians?
0.023? Yeah. Is that what you just said?
Negative 0.023.
Yeah, that's fine.
Yeah. I just put a 0 in front of the decimal. Yeah. All right, then I'm gonna do the same thing this time. I'm gonna find the y. So second apps, go down to polar to ry. On the same point, so 2.5 comma 1.58. And I get the y is 2.4998, so that's gonna go to 2.5.
Negative 2.5.
No, it's positive.
Oh, wait.
Yeah. So this time I'm going to rectangular, which means it's x comma y equals negative 0.023 comma 2.5. For this week's